Hello, everyone. My name is Salesh Divedi. I am the product manager for Oracle True Cache. I'm going to be talking about how to accelerate your applications with True Cache, which is a true SQL and object cache. To accelerate performance, applications use a separate cache cluster. Examples of such cache clusters include Redis and Memcached. Reads that do not need the most current data are directed to the cache. Writes and current reads go to the backend database since that is the source of the truth. Such object caches have various shortcomings, and let's see how TrueCache addresses them. With conventional object caches, developers are responsible for loading the data to the cache. When the application starts, it reads the data from the database and loads it in the cache. Subsequently, on each cache miss, the application reads the data from the database and loads it in the cache and then returns the data to the application. In such scenarios, developers have to write custom code for loading the data in such conventional object caches. Developers are also responsible for cache consistency with the database. The data in the cache becomes stale as the data in the database is updated. Developers have to write custom code to keep the data in the conventional object caches in sync with the database. Some caches work around this by allowing applications to configure time to live for the data in the cache. This doesn't work too well. Frequent invalidations reduce the cache effectiveness and add load to the backend database. On the other hand, less frequent invalidations result in higher chance of getting stale data. Additionally, any schema change in the database can invalidate the entire cache content. Developers are also responsible for cache consistency with other caches. In conventional object caches, each object is independently maintained and is likely to be from different points in time, hence inconsistent with each other. For example, your accounts, when they are cached as different caches, may just not balance. Developers are responsible for maintaining data consistency and integrity in the cache. It's hard to keep the data in the cache correct. Hence, certain types of data that are well suited for caching are not cached. Examples include complex objects with nested relationships, which at times don't change that frequently, are typically not cached. Conventional caches support a limited data type and data formats. Object caches supports only scalar types like string, integer, JSON. Data cannot be accessed in columnar format for, say, analytics or reporting purposes. On the other hand, Oracle Database supports a rich variety of data types like relational, JSON, text, spatial, graph, and vector, and it allows data to be accessed in row or columnar format as needed. Hence, developers must handle the conversion between the rich data type and format supported by Oracle Database and the simple types supported by the object caches. JSON documents exacerbate caching problem. Typically, a full JSON document has to be reloaded in the cache even if one of the attributes in the document changed in the database. This results in increased I/O and load on the backend database. Such caches have many missing enterprise-grade features. For example, object caches lack performance features like multi-threading, parallel processing, subpartitioning, secondary indices, and hence a large cache cluster is typically deployed to compensate for such missing features. Object caches do not have advanced security features like user and privilege management, strong encryption, object level security, row level security, or things like disallowing admin to access data in the cache. Hence, sensitive data cannot be cached. Object caches also lack enterprise-grade features like availability, manageability, and observability, which typically results in lower application service level agreements. Let's look at TrueCache and see how TrueCache solves many of these problems. A TrueCache is an in-memory, consistent, and automatically refreshed SQL and object cache that is deployed in front of an Oracle database. It handles all read SQLs just like an Oracle database. Conceptually, it's more like a diskless active data guard standby. Data in TrueCache is always current and consistent across multiple tables and objects. Schema changes in the database are automatically propagated to the cache. True cache can be scaled with a partition configuration. Multiple true cache instances can be deployed in front of a database for availability, scalability, and to be able to cache large data volumes. True cache also supports spooling data to disk. This allows us to cache much more data volume. For use cases like data residency, user proximity, device proximity, applications are deployed far from databases. In such cases, true cache can be deployed near the application to boost the read performance significantly. As true cache does not store any data on the disk by default, hence, it is considered a data processing tier component that data residency regulations allow. True cache is a true document and relational cache with lock-free concurrency. JSON documents stored in the database can be cached in true cache. Documents are automatically refreshed at the attribute level granularity, hence reducing the I/O on the backend database. Concurrency is automatically maintained with versioning. When a document is read from the true cache, a value-based E tag is embedded in it. When the same document is updated in the database verifies the E tag inside the document and compares it with that in the database to ensure its recency. If E tags don't match, an error is reported back to the application. In such cases, application can read the document again and then perform an update. True cache mitigates deficiencies of conventional caches, like loading of the data into the cache is automated. Cache consistency with database is automated with true cache. Cache consistency with values in the cache is automated with true cache. Cache consistency with other caches is also automated with true cache. It supports complex data type. It has full support for JSON. Comprehensive security is all inbuilt. It supports parallel processing and high availability to provide for enterprise-grade features. Let's see how to use the true cache. The application can query data from true cache in two ways. First, application can maintain two separate connections, a read-only connection to true cache and a read-write connection to the database, and use the read-only connection for offloading read queries to the true cache. Optionally, the application can choose to maintain just one connection. Oracle JDBC driver has been enhanced to transparently route queries to the true cache or to the primary database. The JDBC driver maintains two connections internally and does the read-write split under the application control. The application uses a set read-only API call to mark some sections of code as read-only. This is an existing JDBC API which MySQL already uses for similar purposes. The JDBC driver will send the read-only queries automatically to the true cache, and the writes and the DTLs are automatically sent to the database. True cache can be used to support a variety of use cases. For example, it can be used as a mid-tier cache for boosting application performance. It can be used as an edge cache for enabling device proximity or user proximity. It can be deployed across multiple regions. For example, for use cases like data residency, or it can even be deployed across multiple clouds, again providing proximity for the data to the application. Oracle True Cache offers several benefits to the business. It enables significant cost saving by improving application performance without having to rewrite the applications. It does not require any additional investment in new caching products or new operational skill set. The management and the operational skill for true cache are the same as in Oracle database. It can be used as a single cache for different data types and format. For example, document, relational, row, columnar. True cache can be deployed on commodity hardware, which could be of a different shape and size than the ones used for running Oracle database. Such hardware could be low cost. True cache offers stronger security, which comes with Oracle database, and it allows applications to leverage the full power of Oracle database. Here is some customer feedback we have received. We have many customers who have been evaluating True cache. One of the biggest stock exchanges in the world has been evaluating True cache to offload read queries for some stock tickers. The data in the cache would be around 10 terabytes, and the data in the primary database is around 200 terabytes. Deploying 6 true cache instances, which are primarily for load balancing, which otherwise would have required over 200 node Redis cluster. One of the biggest mobile phone manufacturer is evaluating TrueCache for offloading their read queries as their primary database is maxed out with vertical scaling. One of the biggest financial institutions is evaluating TrueCache to offload their fraud detection application's AI model inferencing, as the models are trained once a day and most of their fraud detection queries are read-only, which can be easily offloaded to TrueCache. One of the biggest marketing companies in the world is evaluating TrueCache for running their real-time marketing campaigns. The data in the conventional caches tends to get stale, and it does not allow for real-time tweaking of marketing campaigns as the data in the database is changing. Oracle Fusion application is evaluating TrueCache to cache some complex business objects which have nested relationships and do not change that often, which otherwise were never a candidate for caching. Oracle's banking application is evaluating TrueCache to offload all the read queries to the cache and hence improve performance. Let's look at some of the performance benchmark test results. We observed a linear throughput improvement by adding low-cost TrueCache nodes. In this experiment, we ran a workload, which is an online transaction processing JDBC workload modeling online shopping and e-commerce application. It has 84% reads and 16% write split. The primary and the TrueCache instances both had 48 cores. We observed linear throughput scalability as we added the nodes for TrueCache. With one node, we observed almost 2x throughput improvement. With two nodes, we observed over 2.6x throughput improvement. This gives close to a linear speed up without changing the application and by just adding TrueCache nodes. In this experiment, we ran the same online transaction processing JDBC workload, and we measured the improvements in the response time by adding a TrueCache instance. The primary database was heavily loaded and hence was resulting in long response time due to the queuing effect when the CPU is maxed out. Adding a TrueCache instance reduces the queuing effect because the same workload is now distributed to two different nodes. As we noticed, the read queries came down to less than 2 milliseconds. Likewise, we also observed an improvement in the write operations as well, as the primary database was now less loaded and hence was not experiencing the queuing effect. We observed a 10x throughput improvement by using a bigger aggregate cache. With partition configuration, the aggregate cache size of all TrueCache instances can be much larger than that of the database. With this, it results in a lot more cache hits, and hence the data is served directly from the cache. In this simulation, we reduced the SGA of the primary database to 10 gig. This was done to force more cache misses on the database and force it to read from the disk. The TrueCache instance was given over 100 gig of SGA. This was done again to simulate more cache hits for the data being accessed from the TrueCache. The workload was Swing Bench, and we noticed 10x performance improvement because of higher cache hit ratios with TrueCache. This experiment was done to measure performance improvement due to the cache proximity. The primary database was deployed in Mumbai in India, and the application was deployed in Phoenix, United States. The SQL round trip between Phoenix and India is around 600 milliseconds due to the distance. Adding a TrueCache instance in Phoenix reduced the SQL round trip to 2 milliseconds for cache hit queries, which is 300 times improvement. This would be expected as the application is fetching data from a TrueCache instance, which is right next to it in Phoenix, versus going all the way to Mumbai in India. Here are the key takeaways. Oracle TrueCache is most fully featured SQL and object cache. The data in the cache is automatically refreshed and kept current with the primary database. It offers full Oracle database capabilities, and it supports leading-edge AI capabilities such as vector search. Oracle TrueCache is a true cache with less effort. So why settle for less?